Thank you, Mary, and thank you, Inform, for this opportunity to speak to all of you today. My name is Libin Varghese, and I'm a principal consultant at FICO. Today, I'm going to talk to you about the barriers that stand in the way of getting advanced analytic models into production and into the hands of your business user. Now, why is this pertinent now, you may ask? Today, to meet the unprecedented challenges that all our companies and communities are facing, it is imperative that every analytical model or optimization problem that we build make its way to the business user. And the business user can use those models to solve the problems they're facing and get things back on track. I want to tell you about when I face this issue of an analytical model not making it into production the first time. I started my career more than a decade ago as a mechanical engineer in a power plant. And one of my first projects was to create a simple forecasting and reporting engine for the daily power generation of the power plant. The business user who I was building this tool for was upper management. Every day, they wanted to understand what the current state of the power plant was, how much power we are generating, forecast for the month, any bottlenecks, if any, etc. I did my research, built a nice little forecasting algorithm, and embedded it in Excel for my business users to run. Not your regular Excel, but the one with fancy charts, macros, and buttons built with all the eagerness you would expect from a first-timer. My manager loved it. But then he asked me a few questions. How is the business user, the VP, going to run this Excel file? Do we install Excel and VBA on his Mac? What if the COO needs to run it as well? Do we need to get her set up as well? And more importantly, if there is a change, how do you get a new version to these folks? I had built the coolest solution, or so I thought, but I faced a barrier in deployment. I had no way to get it into the hands of my business user. Funny thing is that this wasn't the last time I had seen this happen. It's happened again and again and again. Not just for me, but I've seen it happen with a lot of companies that I've worked with as a consultant. And now listening to me, I'm certain that you all have seen this before as well. Everyone must have had that cool model that worked beautifully, but is now sitting on a shelf somewhere because it just couldn't get over the fence to the business user. Don't worry, it's not you or me. In fact, Gartner estimates that 50% of advanced analytic solutions fail to get to the intended audience, the business user. Think of that, 50%. And if we are all building solutions that don't get to the business user, then our companies and communities are not gaining any return of investment from it. And if we don't get any return on investment, what more is it than just an academic exercise? Now, if you think about it, what we're all trying to do is straightforward. We start with a business problem that aims to increase profits, reduce costs, or mitigate risks. We have troves of data to mine, and we have data scientists and OR scientists smart enough to solve the problem. Ideally, these three combined should give us the business solution, but it doesn't. That's what I want to talk to you all about today, about why this process fails and what are the barriers in this process that cause it to fail. And I want to show you, of course, how to overcome these barriers and get our models into the hands of the business user. To do this, I'm going to take you through the journey of an analytic project from conception to delivery. And I want to focus on three barriers that we commonly come across in this journey and how we can overcome them. Let me introduce you to two groups of people that we'll use for this exercise. First are the operational research analysts or data scientists. I'm going to call scientists in this talk. The scientists are the folks who are tasked with building uber cool models using the latest technology to predict or optimize a business need. The second group of people are the business users. Business users are the folks who oversee the day-to-day business of a company and are tasked with meeting business needs like increasing profit, improving customer satisfaction, etc. Let me also introduce the analytic problem that we'll be following in its journey from a mere concept to an actual solution. It's a textbook marketing optimization problem. I'm a marketing manager at a bank, and I oversee deciding what marketing offers to send to my customers. I have three types of offers: credit card offers, auto loan offers, and home loan offers. And I want to make sure I send it to the right customers using the right channels. My status quo is that I've been doing this based on my intuition of running this business for the past 20 years. But now we have a lot of data on consumer behavior. We have a great advanced analytics team, and I'm interested in seeing if maybe they can give me a better way to do these things. So I reach out to the scientists and I tell them about my problem. They're super thrilled and they're convinced that they can do better than my manual approach. So they go out and build a model. 2 months have gone by and I get reports every now and then of, yes, it's working great. We're seeing an accuracy of 90%, an optimal gap of 1%, whatever that means. But hey, our budding analytic problem has gone from a simple concept into some real code. And eventually I get to see the results. And when I take a look at the distribution of offers, I see that 80% of the offers were credit cards, 15% were auto loan offers, and only 5% were home loan offers. This doesn't work in a practical sense because I need to promote our products more broadly. If I go with this in a strategy into production, my home loan product manager will not be happy. Right? Now, the scientists did nothing wrong. But if I'd seen this earlier, I would have told them that we have to make sure that we offer a higher mix of different products, something like this, so that we're promoting a wider range of our products to our customers. Now, once I give them this information, they go back and tweak their model more, right? And we iterate through some more changes. As we do this, time keeps on moving. 2 months become 3 months, 4 months, 5 months, until we finally agree on a solution. Now, what is the real challenge here? You could argue that if we had far more touch points as part of the development cycle, this wouldn't have happened. So you could say that my team's approach was a more waterfall approach of development. And if we had used a more agile development process, this disconnect between the business user and the development team wouldn't have happened. I'm going to say that this alone wouldn't have helped. Why? Because the languages that these two sets of people are speaking are completely different. The scientist is talking in terms of area under the curve, mean squared error, correlation metrics, optimality gaps. The business user is talking in terms of customer satisfaction, profit, costs, etc. But another way, the scientists are looking at these charts to evaluate the solution. And the business users are looking at these charts to evaluate the same solution. And they're not the same. See some semblance of a barrier here? Indeed, this is the first barrier standing in the way of our analytical problem going into production. A reason a lot of advanced analytic models fail to get deployed is simply because scientists and the business users do not speak the same language. So how do we solve for this? First, we need to have the business users and the analytic teams agree upon a common metrics to measure the performance of a model. These can be as simple as agreeing that the model should have an area under the curve greater than 0.7 and the profit should be $500,000. Finding a set of common metrics can take time, right? But it's worth it. And in my experience, it is best if these metrics are more in business terms than in operation research or data science terms. Optimality gap means nothing if in order to implement a solution, I have to completely reorganize my business to achieve it. Right? Now, just agreeing on common metrics is not enough. Scientists must have a way to give the business users a preview of the model and the results in the agreed upon common terms while they're building the solution. So when I, as the marketing manager, had my first presentation with my scientists, they should have presented in the agreed upon common metrics. And then in every iteration, work to make sure we meet the goals defined on these common metrics. This agile process is what will get the scientist and the business users speaking in the same language. So now that we have vanquished the first barrier, let's continue on our journey. Two more barriers remaining. At this point, the business user and the scientist have agreed upon a solution to the business problem using common metrics through an agile process. The next step is, how do you get this Python or R solution from the scientist development environment to the business user's production environment? The main challenge with getting the code or an algorithm into the hands of a business user mostly comes down to two things. And we'll take these barriers, and these are the two barriers that we'll tackle one by one. The first challenge is building a user interface for your model to allow your users to interact or get any user interface into your models. And there are many ways to get a user interface for your models. The most common one is to use a wrapper around your code with another application that has a user interface. For example, remember my complicated Excel file? Why did I really use Excel back then? Because it came with a user interface. I just had to build my model. So our scientists could package the agreed upon marketing optimization code into something like this that can be deployed onto the business user's laptops. What are the drawbacks of such an approach? First, it doesn't scale once you have many users. Imagine you're building a solution that needs to be used by 100 people. And let's say you've built a desktop application, like wrapping code in an Excel user interface. This means your solution has to be now deployed to the machines of 100 people. If your applications need setup, and if you're like any normal organization where people have different types of laptops and machines, imagine the effort it takes to simply set the users up to run your solution. Now think of what will happen when these 100 people start sharing results with one another. And one of the results don't match. Jeff is going to say his version is correct, and Jane is going to say hers is. Chaos, because there is no single source of truth. Everyone has their own version. So they bring you, the developer, in as a referee, and now consider the effort required on your part to debug your solution. No one writes bug-free software, right? So say you find the issue and you have a fix. So you need to push a new version to all 100 users. It simply does not scale. Now, just to be clear, there are cases when Excel works, right? But most enterprise solutions, it doesn't. So reasonably, after running into all of these issues, you might think to put it on a central server, to put the solution on a central server. The main challenge here is that any production-ready solution, like we said before, needs a user interface. Have you tried creating a user interface on a Linux machine? So you do what any sane person would do, and you would put a command line script around your code. And what does that look like? Basically, the user logs into a central machine, uploads a CSV file with the data needed to run the problem, runs a command line script, and that produces an output file. Then the business user is tasked with taking this output file and then putting it into whatever tool they want to visualize the results. Could be Excel or a BI tool. And they perform further analyses to get the solution they're looking for. And that could work as a user interface because by definition, it does allow the user to interface with the model and run it. But that won't be very efficient, would it? In either of these scenarios, desktop applications or server-based command processes, what I've seen happening time and again is that business users will use a solution for a bit, but soon give up because it's simply not flexible for running their business. But the business problem still needs to be solved. My marketing optimization problem is not going anywhere. So who is the best person to run the solution? The one who is the most familiar with it, the one who knows how to debug it, the one who can have a single version of the solution. Who is that person? The same scientist who built the solution. And now this scientist has to devote 2 days a week to running scenarios for the business user. That is 40% of their working time. And what could this scientist have been doing instead of this? Doing what someone with their skill set is best at doing, building more models to solve all the other problems that the company is facing. We know that we all have a giant backlog of problems that we need to solve. They could have been doing that. So what is the alternative to data scientists and operations research analysts hacking together a user interface for the solution? The scientists could go and talk to their IT partners and tell them that they need to get a solution to the business user and that they have tried to do it themselves, but the solution doesn't scale. IT can take the Python or R model and recode it in Java, C# or JavaScript and build a user interface that is scalable and then give that to the business user. But that comes with its own challenges. IT organizations don't move that fast. And for no fault of their own, mind you, they just have a list of tasks with higher priorities. If you're lucky, you will get a position not at the end of the queue, and hopefully your cool solution using an automatic decomposition mixed integer linear programming model gets to the business user in 6 months of time. By which time the problem has changed, the data has changed, and your model definitely needs retuning. But let's say you do manage to get into the front of the queue because you're working on a really important problem. Even then, it's not like this process does not have its own development challenges. Let's think of what's going to happen here. The first portion of a project is when the data scientist and the business users are working together, defining the problem, agreeing upon the common terms, and coming up with a solution. Now, since there was no easy way to get the solution to the business user, we brought in our IT friends to build a user interface and to scale. This takes a long while. When this has completed and we finally release this to the business user for user acceptance testing, this is when the real problems and the bugs start coming up. So we go and get the scientists involved again and ask them to take a look at the problem or the bug. By this time, the scientist has forgotten about the problem, as it has been months since they have worked on it. So it takes time for them to get back into the groove. And more importantly, by now, the business problem again has probably changed, which means retuning, recoding, etc. And this brings us to the second barrier in our journey to deploying a model. Scientists must be able to build a production-ready user interface to avoid IT bottlenecks and get directly to the business user. How do we get over this barrier? Most of today's user interfaces are web-based, and my scientists don't have web development skills. They don't know HTML or JavaScript or any of the latest web development technologies. How are they going to build out a user interface? One way for scientists to get over this barrier is to have access to a no-code way of creating UIs. For example, a drag and drop method where scientists can drag widgets onto the screen to create a user interface. Here's an example where on the left-hand side you have widgets for tables, charts, forms, etc., which the user can drag onto an artboard to create a user interface. With technology like this, the scientists can focus on what they're best at, building analytical models, and not worry about the technologies around how to build a user interface. But if you keep aside the technology that the scientist, that allows the scientist to build a user interface, the more important part is that the same person building the model is the person building the user interface and interacting with the business user so that there's no handoff to a third team. This is invaluable in compressing time to get a solution out. You've probably heard of the game of telephones or Chinese whispers, right? You have a group of people in a line, and the person at one end of the line whispers a message to the person next to them. And this person whispers that to the next person. This keeps on going until we reach the end of the line. And the last person says out the message out loud. The fun of this game is that the story of the message is no longer the same as the original message. Errors start creeping in based on how each person interprets the original message as they heard it. Same thing happens in software. The more people you have to hand off your solution to, the more errors creep in. So imagine being able to pair up two scientists in your team with a business user and all of them together, being able to build an actual production-ready software without any other handoffs. Very powerful, very powerful. So we have solved for the user interface issue. A scientist is able to build an interface now, right? So let's step back into our journey and see what we have done so far. We've built an algorithm that solves a business problem with the results measured using the common metrics we defined. We have now, with drag and drop technology, built a user interface for our business users. What does that mean? Does it mean we have done? Have we built the full solution? Not yet. How is the user going to use this fancy user interface? We still don't have a way to deploy to the business user. And why? Because of the third and final barrier in this journey. Scientists do not have an enterprise-ready platform for deploying advanced analytic solutions. We have technology platforms for data. We have technology platforms for cloud computing. We have technology platforms for a lot of IT needs. So shouldn't scientists have a technology platform for deploying advanced analytics? What is an example of a platform, you may ask? Take any of these smartphone ecosystems that exist. These are platforms, right? A developer in this ecosystem is able to build their app and deploy to the users in that ecosystem. The users are on the same platform, and all they need to do is go and download that app. Imagine if all the app developers had to interface directly with their users and manage it independently. Chaos. So why should we not have such a system for advanced analytics? It's not just important to be able to deploy easily to your audience in a consistent manner, but developers also need to leverage enterprise-grade features that IT organizations expect from modern technology. For example, security is something that every enterprise solution needs. When a scientist is building their application, I shouldn't have to worry about how to authenticate users to use that application. Scale is another major component. If I deploy my solution to the 100 users as a developer, I shouldn't need to worry about how to scale the solution. These are things that the platform should provide, right? For example, in order to scale, I'm sure you've heard of containerization technology or elastic computing or worker nodes, right? The platform should use such technology to scale. As a developer, I only need to deploy my solution to this platform, and that should scale. Next is stability. The ideal platform should provide stability to all the applications that are on that platform. The last thing you want to do is wake up at 2 a.m. to debug the application just because it crashed, right? And finally, the platform should provide repeatability. What happens when you want to build the next cool solution? Once you build one application, you should be gaining skills for building the second application. Each application that you build reduces the effort required for the next application. If you don't have a platform, you do the exact same thing again and again and again. You work in a silo. validate it independently with the business over the course of months. And then since you have no way to deploy, you call in IT, or you get more scientists to run the scenarios for the business users, and this doesn't end, right? To be effective, scientists must have an enterprise-ready platform to deploy all of their advanced analytic solutions. So now here we are at the end of our journey, broken down 3 barriers, and the scientists and the business users are now working on the same solution that is now enterprise ready. Right? Let's look at how our project timeline changes with all of these barriers removed. Here is the old way of doing things, where the scientist and the business user work together, agreed upon a solution, and then handed it off to IT, who went in, did their thing, and then that process was long drawn. This is a process for one app. In the new way, our scientists can build a model, the user interface, and also deploy to their business user. Let's take a second. What does this really mean? It means that at the end of every iteration, the scientist can give the business user a version of the final solution. Think of that. Every time a scientist is working on a solution, they're working on the actual solution, right? It's prototype version 1, prototype version 2, and the last iteration is the actual solution. One cool thing about this is that we get feedback so much earlier in the process, right? Because the business user is giving this frequent feedback back to the scientist, another thing starts to happen. This application begins to look familiar to the business user. And that means, since the user is working on the same app every time, just incrementally getting better, that will automatically lead them to be more comfortable with the solution, and hence lead to a much higher adoption rate. Right? The user acceptance test in this case is very fast, because this is not a new solution for the user. They've been using this for a long time, from prototype version 1 to 2, and now it's just become the final version. So frankly, there's not much to test anymore. So finally, we have successfully removed the barriers in the way of deploying not just this solution, but for all of our advanced analytics solutions. And in summary, here are those steps. Business users and scientists should speak the same language, so that they agree upon a solution to the problem. Scientists should be able to build a production-ready user interface, so that they don't have to bring in a third team to build it for them and lose requirements in the way of discussions. And finally, scientists, after they have built a solution, should have a platform to deploy this and all of the other solutions to their business users. And that brings me to the end of the presentation, and I hope this causes you to evaluate if these barriers exist in your organizations, and then work towards overcoming them and deploying all of your advanced analytics solutions to your business users. Thank you.